Hi friends, today we are going to discuss another design pattern of distributed systems called single socket channel. Now in this design pattern, the problem statement is, let's say we have two servers who want to communicate with each other in a defined order. By defined order, I mean if, for example, this follower sends a particular request to the leader, it should get the response in the order of the request that it is sending. So what it is going to do is it is going to open a single socket channel to the leader, and then the requests that are going to the leader, are getting logged in the singular update queue, and with this the leader is applying the operations one by one with a single doer of this update queue. We have discussed singular update queue in another video. Now the doer is doing the operation, and as soon as the operation is done, the response is sent back to the single socket channel, and at the receiver end, again it is up to the receiver whether it wants to handle the responses in the singular update queue. So this is leader follower single socket channel. Now what are the advantages of single socket channel is it is ensuring that the ordering of the requests and responses is adhered to. Also, you're not creating connection for every request that you're sending between the servers. You are using the single socket channel and queues at each end of the channel to ensure that the processing of messages both at the sender and receiver is being done in order. Also, if any request fails, for example, you have sent a request and it fails, you can retry because you are ensured that the processing is going to be done in ordered fashion by the leader as well as follower. And since you're not establishing connection every time, your latency is going to come down because network establishment cost is high in systems of critical importance. As soon as the connection is established, both end of the leader and follower, or both the nodes, start listening to this channel for any requests that are incoming, and this channel is always established with a timeout. So that if there are no requests in a particular duration, then you can dissolve this channel or break down this channel. And to ensure that the latencies are low, so what we do is we send dummy packets across this channel which are called heartbeat, so that we can be assured that whenever we want to send a packet over this channel, the connection is always established and we are having a reliable connection between the nodes. Now, since we have a heartbeat and we have a timeout, we have to ensure that our timeout values are multiples of heartbeats. So let's say we send a heartbeat every 1 second. So we can set the timeout values as 5 seconds, which means that if we are not able to get any heartbeat in 5 consecutive, we are not getting any heartbeats for 5 consecutive times, we can time out this channel, single socket channel. Since we are sending only one request on the channel at a time and waiting for its response, this can cause head of line blocking in scenarios where we sent a request and it is taking a lot of time. So the requests which could have been sent parallelly were not sent and are being blocked by a single request. So this is the single socket channels problem, and it is solved by the request pipeline model, which is discussed in another video given in the links description. Now, Kafka and Zookeeper, they both extensively use single socket channel for communication. Kafka uses a single socket channel for replicating data between leader and followers. All the data from leader to follower is sent via single socket channel, so that the ordering of the messages in the Kafka's topics partitions is ensured at the follower end also, And the follower, when it is writing that data, it is also ensuring that it is using a singular update queue, so that the requests are written serially and the ordering of the messages in the topics partition is maintained. Similarly, Zookeeper ensures a single socket channel is established between all its clients. For example, let's say there are two clients, C1 and C2. They want to interact with the Zookeeper. They have to open a single socket channel with Zookeeper, and all the interactions, all the watches, all the updates that it is getting, it is going to get over a single socket channel. Also, the state watch pattern in where we discussed that callers are setting a watch on key value pairs or KV store or consistent core stores. They are also opening single socket channels so as to ensure the ordering of the events that they are getting from KV store. Also, it ensures that large number of connections are not established for creating watches on multiple keys. That is all for the single socket channel. I hope you liked the video. Thank you and have a nice day.